Let's explain the formal definition of big O, which states that the time complexity of an algorithm is the order of a function f of n if there are positive constants c and n naught such that t of n is less than or equal to the constant c by the function f of n, when n is greater than or equal to n naught. So the idea is to establish a relative order among functions and also compare the relative rates of growth. Because two functions can be smaller than each other only at certain points. So as an example, let's compare this function 1000n to this quadratic function n squared. So although the linear function 1000n is larger than a quadratic function for small values of n, so specifically n less than 1000, we can see that n squared grows at a faster rate. So using the big O definition, there's some point n naught where c multiplied by f of n is at least as large as t of n. And for example, where c is 1 and n naught is 1000, so this inequality where t of n is 1000n is less than or equal to 1 by f of n holds. So we say that 1000n is order n squared, or O(n) squared. And note that there's other constants where this inequality holds. So for example, when c equals 100 and n naught is equal to 10. Please subscribe, like and comment to help me reach more students.